Today, guys, we're going to continue what we started in. We started in chapter 9 talking about stoichiometry, and we said stoichiometry just kind of calculation that is in care about the relation of the masses between reactants and products in chemical reaction. So we just give a big idea or like intro about stoichiometry in the last section. We know what are the types of stoichiometry and what are the possible problems of stoichiometry that we're going to deal about. Today, inshallah, we're going to pass in section 2, which we're going to talk about the ideal stoichiometry calculations. We're going to know, okay, we're practicing the different types of stoichiometry problems and how we could solve it. So in the beginning here, as we said last time, stoichiometry always depend on a balanced chemical equation. And we said balanced chemical equation is a must. Why balanced chemical equation is a must, or why we cannot work without a balanced chemical equation? Because actually balanced chemical equation, it gives us the ability to figure out the mole ratio between reactants and product. That means it could give us the idea how many moles of this reactant could produce how many mole of this product, or how many mole of the reactant gonna react with how many mole of the other reactant, and so on. So like that, okay, Pann's chemical equation enable us to find the mole ratio in which we could find the relation between the moles, and then we could convert them into masses later, okay, between reactants and products. And also that satisfy the law of the conservation of mass. As we said, mass neither be created or destroyed. So we cannot work with an unbalanced chemical equation, because if it's unbalanced, it will not represent the accurate, okay, relation or the accurate mole ratio. So, and that will, of course, okay, will not be true or will not be accurate. So here, like this, that's first, or that we just repeat why we must start why passive chemical equation. In the stoichiometry, or actually the different calculations of system geometry, it's theoretical. What mean by theoretical? That means it's not must be practically happened. That means once I say in a chemical equation, let's take an example. When we say a chemical equation like H2 is going to react with O2, so to produce H2O. Okay, so here like that, guys, we know that hydrogen was going to react with oxygen to produce water. Okay, so if we just want balance in this chemical equation, here we just have two hydrogen, here two hydrogen, but here we have two oxygen, just one outside. So we need to add a coefficient 2, which make now we have 4 hydrogen, so we're going to put 2 here. So like this, it's a balanced chemical equation. So in this chemical equation, even we didn't did this reaction in lab, we could figure out that we need 2 moles of hydrogens to react with 1 mole of oxygen to produce 2 moles of water. So like that, it's a theoretical. That means, okay, I could predict the maximum amount of the product that could produce from certain amount of reactants, and also I could predict what exactly the amount of reactants that I wanted to react to produce the product. So actually, the chemical equation that represent, okay, that the product is produced due to the completely consuming, or the completely usage of the entire reactants. Even some chemical reactions in lab, not all the reactants are completely involved in the reaction, or they are not completely consumed in the reaction. Some of them is we're gonna react, and the others will remain or stay as it is in the beaker or the tube or the container that I'm making the reaction in. But we still using the stoichiometry because it gives us the hint or the idea about how we are gonna, what are the predicted amounts of products, and also what are the needed amount of the reactants to get certain amount of products. So here like this, guys, we said that the the reactions stoichiometric calculation described in the chapter are theoretical. That mean, what mean by theoretical? That means they tell us the amount of reactants and the products which are given for a chemical reaction ideal conditions. That means in the normal condition. So here, like this, in which all the reactants are completely converted into products. However, some reactions do not proceed, such as this. That means that not all the reactants always convert into products. But okay, this kind of theoretical calculations or theoretical stoichiometry give us to predict how much product will be produced from a certain chemical reaction, and how much the reactants need in this reaction. So let's find, okay, different problems or different kind of problems that could we have in stoichiometry. First one, conversion or conversion of quantities in mole. That means once it give you the amount of mole, okay, the amount of substance, known substance in mole, and he asked to find the amount of unknown substance in mole. So what are the steps which we are gonna find it? Okay, first of all, we should have a balanced chemical equation. So the first step, we are gonna have a balanced chemical equation. So first, balanced chemical equation. Then we are gonna use this balanced chemical equation to find the mole ratio between the known substance and the unknown substance. Then multiply, or we could multiply the given quantity to the conversion factor or to the mole ratio. Then multiply the given amount to the mole. So let's that three steps here, guys. So the first step, we should have the balanced chemical equation. Second one, find the mole ratio. Okay, and third one, okay, we are gonna multiply the given amount to the mole ratio which figure. Let's take a practice to find this. Okay, so we're gonna keep the steps here and let's find this one. Okay, so he said that he give you here already answered practice. Let's try to find what he asks about. So in that one, he asks you in a spacecraft, the carbon dioxide exhaled by astronaut can be removed by the reaction with lithium hydroxide (LiOH) according to the following chemical equation. And he got you, or he already provided you with a chemical equation. First step, we're gonna do it. What we should do in the first step, guys? What we should do in the first step, guys? Regarding what as I wrote, guys, what we should do? Hey.
Balance the equation.
So first we must check if this chemical equation is balanced or not. Okay, so here we could find that carbon dioxide, one carbon here and one carbon here. Here two oxygen and here one, so they are three in the reactants, and also here we have sorry, here two and here two. Okay, so four in the reactants and four in the products. Okay, two lithium and here two lithium, two hydrogens and here two hydrogens. So overall the chemical equation is balanced. So the first step, we check that it's balanced chemical equation. Second thing, let's find what he's talking about. He said, according to this chemical equation, he said, how many moles of lithium hydroxide, so that is the unknown lithium hydroxide, okay, are required to react with 20 moles of carbon dioxide. So the given is the carbon dioxide. So this is the given, while this is the unknown. So he asks you, what about 20 mole of carbon dioxide? It will react with how many mole of the lithium. So the second step, find the mole ratio. So let's find the mole ratio, guys. Who can find the mole ratio between carbon dioxide and lithium hydroxide?
هتبقى 40.
I didn't ask for the answer. I'm asking now. Tell me, what is the mole ratio? Yes, Guda.
1 to 2.
1 to 2. So we're going to say 1 carbon dioxide, okay, over 2 of lithium hydroxide. Good. Okay. So the ratio is 1 to 2. So then we're gonna multiply by the given amount. The third step, we said that multiply by the given amount. The given amount is 2 or 20 carbon dioxide. So 20 carbon dioxide multiply, okay, 2, sorry, okay. So here we said that 20 carbon dioxide, and that's so what the results we're gonna have, okay, as a cross multiplication. So they are gonna be, so to ensure that mean here how much we need. Okay, so we're gonna make kind of cross multiplication. So 20 multiplied 2 over 1, it equals
40.
40. So like this, we get 40 mole. We need 40 mole, okay, of lithium hydroxide. So you get the idea, guys? Is it clear? Anyone can't understand, guys? Your silence means that you understand. Because we're gonna pass through kind of practice, okay, and I'm gonna ask you to answer questions. So if you can't understand, please ask. Okay. So again, the steps, first of all, we check that, or we write the balanced chemical equation, then find the mole ratio between the required substances, Then we start to make kind of cross multiplication, okay, to find the unknown amount or the needed amount. Let's try, okay, to find or to get more practice. Okay, so here, guys, he asks you ammonium NH3 is widely used as a fertilizer in many household cleaners. Okay, so how many moles of ammonia are produced when a 6 mole of hydrogen gas react with the excess of nitrogen gas? So what the first step we're gonna do? Who can answer this question? Let's share, guys. Who can answer this question? If you know the answer, just raise your hand, or if you know even the steps, just practice.
تبقى 2.
I didn't ask for the answer. Just tell me the steps. How we're gonna do
خلاص
it? For the first step,
steps
Hassan.
معمول. طب ماشي ما
First
الستبس
step.
اللي هو بتاع فيبقى 1 2 3.
How could you know? First step, we must write the balanced chemical equation. You get idea? How could
اللي
you
هو
know the ratio if you don't have the equation?
طب ماشي.
So the first step, we're gonna write the balanced chemical equation. What are the reactants? He said it produced when, okay, hydrogen react with nitrogen.
nitrogen gas.
So what is the symbol of hydrogen?
H.
H, and must write 2 because it's a diatomic element. Don't forget. Okay, it will react with nitrogen with N2, so that's gonna yield the ammonia, which is NH3. So like this, we already wrote the chemical equation. Is it balanced, Hassan?
No.
No. So let's try to balance it. How we could balance it?
ثانية.
Just simple. How many hydrogen here?
هيبقى في الهيدروجين هنحط 3
So here 3. Good.
2.
Good. So like this, we wrote the balanced chemical equation. That's the first step. Then we're gonna find the mole ratio for the required. He asking about how many moles of ammonia. So that's what we needed. Okay, when 6 moles of hydrogen. So we need to find the mole ratio between ammonia and hydrogen. Okay, so we said that 2 mole of ammonia. Okay, the mole ratio over 3 moles of hydrogen. Yes or no? You got it? So here we're gonna find, he asks about how many mole of hydrogen do we have?
6.
So we're gonna multiply 6 mole of hydrogen. Okay, so like this. Okay, what we're gonna do here in that case? So 6 multiply 2.
Cross multiplication.
So cross multiplication, yes. So 6 multiply 2 equal 12 over 3. That's equal
4.
4. So that's mean we need about 4 moles of
nitrogen.
4 moles of, no, he's asking about what? How many moles of ammonia? We get ammonia. Okay, so that will produce, okay, that means once we have 6 moles of hydrogens, they are gonna produce 4 moles of ammonia. You can make it in another simpler way, guys. If we could say from the chemical equation 3 mole of hydrogen already produce 2 mole of ammonia. Okay, so if we have 6 mole, how many we need? Is it easier? That way is easier. Okay, so we're gonna 6 multiply 2 divide, so that's here multiply, and then we're gonna divide by this. So 6 multiply 2 divided by 3. Is it hard like this, guys?
No.
Okay, so I'm gonna give you just about 1 minute or 2 minutes, okay, just to try to make the second one, everyone. Okay, then I'm gonna pick randomly to find your answers. Okay, so the decomposition of potassium chlorate KClO3 into KCl and O2 is used as a source of oxygen in laboratory. How many moles of potassium chlorate are needed to produce 15 mole of oxygen gas? Everyone start working. If there is any problem while you are working, you can ask. No one after okay time when I ask, he said I can't, I don't. Okay, so please try. Hurry up, guys. Okay, let's find who can answer. Number 2. Let's find here. Yes, Lolwa?
Yes, mister.
Let's try. What the first step, Lolwa? Lolwa? Mariam? Mariam,
Yes, mister.
could you please try with me in that question?
Yes.
So the first step, what we're gonna do?
We will balance the equation.
We are gonna write the balanced chemical equation. So here he asked the decomposition of potassium chlorate into potassium chloride and so what would the chemical equation which we're gonna write? K
KC.
ClO3, that's potassium chlorate, will decompose. That means it will break down into
So KCI.
yeah, KCl, chlorine,
N. Sorry.
plus O2.
O2.
So then check, is that chemical equation is balanced?
Yes.
No, here we have 3 oxygens while here we just have 2. So we need to balance the chemical equation. What we should do now? How to balance, guys? Here we have 3 oxygen while here we have 2. So how we could make this side equal to this side? Okay, so simply we're gonna add here 3. Okay, and here we're gonna 2. Okay, so like this we have 2 potassium here, 2 potassium here, 2 chlorine, 2 chlorine. Here we have 6 oxygen and here we have 6 oxygen. So like this we get a balanced chemical equation. Okay, Mariam?
Yes.
So we already did the first step. Then he asking about, okay, how many moles of potassium chlorate are needed to produce 15 mole of oxygen gas? So here like this, how many mole of potassium, how many mole of potassium chlorate here? How many mole here?
5.
They are 5. That's
Two.
we determine the number of moles by the coefficient. So here we have 2, so we have 2 mole of chlorate. So we said that 2 mole of of KClO3, they produce how many mole of oxygen?
3 moles.
They produce 3 mole of oxygen. Good. Okay. So then we find, then we try to find here. Okay. He asking how many moles of potassium chlorate. So that is the unknown. That gonna produce 15 mole of oxygen. So just could you find it? Kind of cross multiplication. So it will be 15 multiply
2.
2. Good. Divided by
30 divided by 3.
good. Divided by 3. So
10.
good. Excellent. So 15 multiplied by 2 divided by 3 equals 10. Okay, mole. So like this, we need 10 mole of potassium chlorate to produce 15 moles of oxygen. Is it hard like this, Mariam?
No, I understand.
So first step is the most important one, that you have the balanced chemical equation. So don't forget this. You must ensure that it's balanced. Okay, guys, is it clear? Any hard question, guys?
No, mister.
Okay, so here then we're gonna say, okay, like that, okay, that the first type of problems that we could have in stoichiometry, and that the simplest one, that we change from mole to mole, okay, or mole of or given substance in moles to no unknown substance in moles also. So let's pass to the second type here, when we try to conversion of amounts in moles to mass. That means here it's gonna provide you, or it's gonna give you a kind of amount of given substance in mole, okay, and okay, he asks you to get unknown substance, but in grams. So first, we must get this intermediate step. We must know this amount of moles, okay? We're gonna give how many moles of the unknown substance. Then we convert from mole to the mass by multiplying the molar mass or using the molar mass. So here, the key, as you can see here. First step, we get the amount of given substance. Then we are gonna find the mole ratio to know the amount of other substance in mole, and then multiply it by the molar mass to get the unknown substance. Let's take a kind of practice to understand how we're working with this, okay? So let's find here. He asks you, in photosynthesis, plants use energy from the sun producing glucose, C6H12O6, and oxygen from the reaction of carbon dioxide and water. What mass in grams of glucose is produced when 3 moles of water react to carbon dioxide? So first of all, we must write the balanced chemical equation as usual. So what we are gonna write the balanced chemical equation. Actually, the balanced chemical equation, as we can see here, okay, that is 6CO2 plus 6H2O yields C6H12O6 plus 6O2. So we get the balanced chemical equation here. Then what we should do, he asks about in the amount of the glucose in grams. So that is the unknown. So he asked about this. That's the unknown, and he required the amount in grams. If we consume about, he just said how many oxygen, 3 moles of water. So 3 moles of water. So the known substance is water, and he asked what gonna produce when we have 3 moles. So what the first step? First step, we should figure out how much the 3 moles of water will produce how many mole of glucose. So regarding to the balanced chemical equation, we find that 6 mole of water, this 6 mole of water, they produce 1 mole of glucose. C6H12O6. So then we said, how much 3 moles of water they produce how many mole in glucose? So who can tell me? First multiplication. So we're going to find 3 multiply 1 divided by 6. Yes or no? So 3 multiply 1 divided by 6. It will produce half mole. So we have half mole of glucose. So that's the first step. We already know the amount of the glucose that will be produced from 3 moles of water. But this amount is represented in mole, and he asks to get them in, okay, grams. So we need to convert, okay, this amount into mass or into the grams. So simply we are gonna find that 1 mole of glucose represent how many gram, guys? Anyone know? Let's try to remember here. So here in that case, we need to remember to know the mass of each element. So in that case, we're going to use the periodic table, okay? Or suppose that you are going to use the periodic table to find. So we said that 6 carbons, which means they are 6 multiply 12, okay? Plus 12 hydrogen, it means 12 multiply 1, okay? And the oxygen, they are 6 multiply 16. So here, let's try to make this calculation. Who can make this calculation? Use your mobile or use your calculators, guys. Hurry up. Tell me, guys, what is the result?
One second.
What? Anyone find?
180.
Good, 180 gram. So the 1 mole of glucose represent 180 gram. So the half mole of glucose, which we're gonna have, represent how many gram? Another cross multiplication. So here we find half multiply 180, 0.5 multiply 180 divided by 1. Okay, so simply it's gonna equal how much? 90 gram Okay, so like this, 3 moles of water in photosynthesis reaction produced 90 grams of glucose. Is it hard like this, guys? Is it hard like this?
No.
Okay, so let's take another practice to ensure that you get the idea. Let's find here. So what mass of carbon dioxide in grams is needed to react with 3 mole of H2 in photosynthetic reaction described in the simple problem P? Okay, so in the same equation which we use up here, he asked to find how much the mass of carbon dioxide we need, okay, from the reaction of 3 moles of. So who can answer this problem, guys? Let's start to practice. We're just practicing together, guys. Let's find here. So what we're gonna do, the first step, what the first step we're gonna do, guys, here. Hassan Ruhaim or Jana Graiha? Okay, Jana.
We'll balance the equation.
It's already balanced. Good. Then what we're gonna do?
Okay. Sorry.
Yeah, you are. No, you are working right. You said the right answer. You balanced the chemical equation, so it's already balanced now. Let's pass to the second step.
He gave us that H2O is 3 mole.
Good. Okay, so first we mark the known and the unknown substance. So water is the known substance. He asked that we're gonna use 3 mole of water. Brilliant. And what is the unknown, or what he asks
Carbon
about?
dioxide.
Carbon dioxide, which is unknown, but he asks to find them in grams. He asking about mass.
Gram.
Okay, good. So what the first step we're gonna do, Jana?
It will be 6
So
moles
6 moles of water. Good. 6 mole of water.
with 6 moles of carbon dioxide.
So producing 6 mole of carbon dioxide. So like this, how many moles of carbon dioxide will be produced by 3 moles of water?
3 word.
So 3. Okay, so we are gonna have 3 moles of carbon dioxide. Good. So that means the 3 moles of water produce 3 moles of carbon dioxide. How much the mass of these 3 moles? Okay, so let's see what we're gonna do. Yes.
12 of 1 carbon
So
dioxide.
1 mole, that means we must find the molar mass. That means the mass of 1 mole. So 1 mole of carbon dioxide, it represents, so 1 multiply 12, that's because we just have 1 carbon. Good. Plus
we have 2 oxygen.
2 plus 2 multiply 16, because oxygen is 16.
16, yes.
So that means 12 plus 32. Okay, so it's equal 44. Yes.
Yes.
So 1 mole of carbon dioxide equal 44 gram. So here like this, how many 3 mole of carbon dioxide equal in grams? So
44 multiply 3.
So good, 33 multiply 44. Okay, so how much is it?
Wait.
132.
132 gram. Brilliant. Okay, so is it hard like this, guys?
No.
Any hard question?
No.
So like this, we just practiced about 2 types of stoichiometry problems. First one, when he give you that known substance in moles and need to find the unknown substance also in moles, the simplest one. Then the other type, which will give you the amount of known substance in moles and ask you to find the unknown substance in grams. So in that case, we must first find the amount of moles of unknown substance, then convert it into grams. Is it hard like this, guys? Any hard question? Any hard question here, guys?
No, mister.
Okay, so you're supposed to study this part from your textbook and try to answer all the practices, okay, that I found in this part, okay? That means all the problems which you found in your textbook till page 308. Try to answer all these questions, and we're gonna just discuss it next time. And if you have a problem while you are working on this kind of questions, I'm waiting for your question next time. Thank you, guys, and goodbye.